Good afternoon, sir, and to my classmates. This is Patricia Teresa Nobinario under the section of 2K2, and I'm here to report about the WAN concept. So, what is WAN? WAN is a wide area networks are a form of telecommunication networks that can connect devices from multiple locations and across the globe. WANs are the largest and most expensive forms of computer networks available today. These networks are often established by service providers that then lease their WAN to businesses, schools, government, or the public. These customers can use the network to relay and store data to communicate with other users, no matter what are their location, as long as they have access to the established WAN. Access can be granted via different TICs such as virtual private networks or lines, wireless networks, cellular networks, or internet access. So, why a WAN? A WAN operates beyond the geographic scope of a LAN. WANs are used to interconnect the enterprise LAN to remote the LANs in branch sites and telecommuter sites. A WAN is owned by a service provider, whereas a LAN is typically owned by an organization. An organization must pay a fee to use the WAN service provider's network services to connect remote sites. Service providers provide links to the interconnect remote sites for the purpose of transporting data, voice, and video. Are WANs necessary? Without WANs, LANs would be a series of isolated networks. As organizations expand, businesses require the ability to communicate between geographically separate sites. For example, regional or branch offices of an organization need to be able to communicate and share the data with the central site. Organizations need to share information either or with other customers organization. Employees who travel on company businesses frequently need to access the corporate network. In addition, consumers now commonly communicate over the internet with banks, stores, and other providers of goods and services. Connecting multiple sites across WANs can involve a variety of service provider technologies and WAN topologies. There are four common WAN topologies. First, let's begin with the point-to-point topology. Point-to-point topology is a way of connecting two nodes, computer, laptop, mobile device, router, hub, or switch, through a common medium. The medium can be wired cable or wireless satellite. It employs a point-to-point circuit between two endpoints. Typically involves a dedicated leased line connection such as T1 or E1 line, transparent to the customer network and appears to be a direct physical link between two endpoints. Next is the hub and spoke. One physical site acts as hub, example, the main office, while other physical sites act as spokes. Spoke sites are connected to each other via hub site. It is applicable when a private network connection between multiple sites is required. A single interface to the hub can be shared by all spoke circuits. Spoke sites can be interconnected through the hub site using virtual circuits and routed sub-interfaces at the hub. Next is the full mesh. Full mesh Full mesh has every device has a dedicated point-to-point link to every other device. The term dedicated means that the link carries traffic only between the two devices it connects. A disadvantage of the hub and spoke topology is that all communication has to go through the hub. With a full mesh topology using virtual circuits, any site can communicate directly with any other site. A disadvantage is the large number of virtual circuits that needed to be configured and maintained. For example, one practical example of a mesh topology is the connection of telephone regional offices in which each regional office needs to be connected to every other regional office. So next is the dual home topology. It provides redundancy and load balancing. However, they are more expensive to implement than single home topologies. It requires additional networking hardware including routers and switches. It is more difficult to implement since they are require complex configuration. An example of dual home devices are Intuos computing motherboards that incorporate dual Ethernet network interface cards. So in slow economic times, many businesses focus on increasing their profitability by improving the efficiency of their existing operations, including establishing and managing their network. To justify such a large expense, many companies expect their networks to perform optimally and to be able to deliver an increasing array of services and applications to support productivity and profitability. This chapter will focus on a fictitious company called Span Engineering. This topic will illustrate how Span's network requirements change as the company grows from a small, local business into a global enterprise. Uh, Span Engineering of Small Office. The small office uses a single LAN to share information between computers, support their VoIP phones, share referrals, printer, and large-scale plotter to develop a special process for converting household waste into electricity and is developing a small pilot project for a municipal government in its local area. Next is the campus network. 5 years later, Span Engineering has grown rapidly. The company was contracted to design and implement a full-size waste conversion facility as well as the other projects in neighboring municipalities around the country. The company is now classified as a small to medium-sized business with several hundred employees. The company now occupies multiple floors of an office building. The network has grown to several subnetworks which spans several floors of the building. The business now has an in-house IT staff to support and maintain the work. It means that every position of the main office, there are different kinds of networks that can connected in whenever they have a position. For example, the marketing and sales. Hundreds of employees work on one or more floors or in neighboring buildings they can connect through the internet. So next is the branch networks. The company was required to implement a WAN in order for remote sites to be able to access the data center, which is houses various databases and servers. The branch office that are in nearby cities uses private dedicated lines through their local service provider. Offices that are located in other countries must use the internet for their WAN connection. Next is the distributed network. Span Engineering has now been in business for 20 years and has grown to thousands of employees distributed in offices worldwide. The cost of the network and its related services is a significant expense. To increase profitability, the company must reduce its operating expense. To meet the new requirements, the network must provide the new necessary converged service and secure Internet WAN connectivity to remote sites. As seen in this example, network requirements of a company can change dramatically as a company grows over time. WAN operations focus primarily on the physical and data link layer of the OSI model. Data link layer requirements include physical addressing, flow control, and encapsulation. WAN access standards are defined and managed by a number of recognized authorities, like the TIA or EIA, Telecommunication Industry Association, and the Electronic Industries Alliance. ISO, the International Organization for Standardization. IEE, Institute of Electrical and Electronics Engineers. Layer, protocols describe how to provide electrical, mechanical, operational, and functional connects to the services of communication service provider. Protocols define how data is encapsulated and the mechanisms for transferring the resulting frames. One primary difference between a WAN and a LAN is that a company must subscribe to an outside WAN service provider to use WAN carrier network services. Terminology commonly used to describe WAN connections is customer premises equipment, or CPE, consists of devices and inside wiring located on the enterprise edge connecting to a carrier. Data communications equipment, or DCE, also called circuit terminating equipment. The DCE consists of devices that put data on the local loop. The DCE primarily provides an interface to connect subscribers to a communication link on the WAN cloud. Next is the data terminal equipment, DTE. The customer devices that pass the data from a customer network or a host computer for transmission over the WAN. The DTE connects to the local loop through the DCE. Demarcation point. This is a point established in a building to separate customer equipment from service provider equipment. Local loop or last mile. The actual copper or fiber cable that connects the CPE to the CO of the service provider. Central office or CO. The CO is the local service provider's facility or building that connects the CPE to the provider network. The toll network. This consists of the long-haul all-digital fiber optic communication lines and other equipment inside the WAN provider network. There are many types of devices that are specific to WAN environments. Dial-up modem. Legacy WAN technology that converts or modulates the digital signals produced by a computer into a voice analog lines of the public telephone. Network to another modem for demodulation. Access server. Legacy technology where the server controls and coordinates dial-up modem, dial-in and dial-out user communication. Broadband modem, a type of digital modem used with high-speed DSL or cable internet service. Both operate in a similar manner to the voiceband modem, but use higher broadband frequencies and transmission speeds. CSU or DSU. Digital list lines require a CSU and a DSU. The CSU provides termination for the digital signal and ensures connection integrity through error correction and the line monitoring. The DSU converts line frames into frames that the LAN can interpret and vice versa. Router provides internet working and use one access interface ports that are used to connect to the service provider. Core router or multi-layer switch. A router or a multi-layer switch that resides within the middle or backbone of the WAN. Circuit switching. A switch network is one that establishes a dedicated circuit between nodes and terminals before the users may communicate. Circuit switching dynamically establish a dedicated virtual connection for a voice or data between a sender and a receiver. Communication can't start until the connection is established through the service provider network. Dialing a number to make a call is an example of circuit switching technology. The two most common types of circuit switch WAN technologies are the public switch telephone network or PSTN and the integrated service digital network ISDN. Packet switching. In contrast to circuit switching, packet switching splits traffic data into packets that are routed over a shared network. A circuit does not need to be established and many pairs of nodes can communicate over the same channel. There are two approaches to packet switch network determination. Connectionless systems. Full addressing information must be carried in each packet. The Internet is an example of a connectionless system. Connection-oriented system. The network predetermines the route of a packet, and each packet only has to carry an identifier. An example of a connection-oriented system is a frame relay. The LCIs are the identifiers. Packet switching costs less than the circuit switching. However, latency and jitter are the greater in packet switching.
And now, good evening, sir, and to my fellow classmates. Now we are going to discuss a selected WAN technology. There are several WAN access connection options that ISPs can use to connect the local loop to the enterprise edge. Each option has distinct advantages and disadvantages as well as difference with technology, speed, and cost. There are two ways an enterprise can obtain WAN access. First is the private WAN infrastructure. Choices may include dedicated point-to-point lease lines, circuit switch links such as PSTN or Isdn, and packet switch links such as Ethernet WAN, ATM, or frame relay. Second is for public WAN infrastructure. Service providers may offer broadband internet using DSL, cable, or satellite access. Data traveling between corporate sites over a public WAN should be protected using VPNs. Let's go first with the service provider infrastructure. Service provider networks are complex and consist mostly of high bandwidth fiber optic media using the synchronous optical networking or SONET or synchronous digital hierarchy or SDH standard. A new fiber optic media development for long-range communication is called dense wavelength division multiplexing or DWDM. It multiplies the amount of bandwidth that a single strand of fiber can support. It also enables bidirectional communications over the strand of fiber. Next is the lease lines. Lease lines vary in price depending on the bandwidth required and the distance between the two connected paths. When a permanent dedicated connections are required, a point-to-point link is used to provide a pre-established WAN communications path from the customer premises to the provider network. Next is the dial-up. Dial-up WAN access may be required when no other WAN technology is available. Traditional local loops, which use copper cabling, transport binary computer data through the voice telephone network using a modem. For example, a remote location can use modems and analog telephone lines to provide low capacity and dedicated switch connections. Next is the ISDN. Integrated Services Digital Network or ISDN is a circuit switching technology that enables the loop of PSTN to carry digital signals, resulting in higher capacity switch connection. ISDN changes the internal connections of the PSTN from carrying analog signals to time division multiplex TDM digital signals. Next is the frame relay. Frame relay is a layer 2 non-broadcast multi-access or NBA WAN technology used to interconnect enterprise LANs. A single router can be used to connect multiple sites using PVCs, which can carry both voice and data traffic. Next is the ATM. ATM stands for Asynchronous Transfer Mode technology, is capable of transferring voice, video, and data through private and public networks. ATM is built on a cell-based architecture rather than on a frame-based architecture. Small thick-length cells are well suited for voice and video traffic. A typical ATM line needs almost 20% greater bandwidth than frame relay to carry the same volume of network traffic. Next is the Ethernet WAN. Ethernet standards using fiber optic cables. Ethernet is not a reasonable WAN access option. Ethernet WANs are commonly being used to replace frame relay and ATM WAN links. Next is the MPLS. MPLS stands for multi-protocol label switching. Is a multi-protocol high-performance WAN technology that directs data from one router to the next. MPLS is based on short path labels rather than IP network addresses. It is called multi-protocol since it has the ability to carry any payload, including IPv4, IPv6, Ethernet, ATM, DSL, and frame relay traffic. It uses labels which tell the router what to do with a packet. Next is VSAT. All private WAN technology discussed so far use either copper or fiber optic media. A VSAT is a small satellite dish used to create a private WAN that provides connectivity to remote locations. The satellite is geosynchronous orbit in space. The signals travel approximately 35,786 kilometers to the satellite and back. Next is the DSL. DSL is an always connection technology that uses existing twisted pair telephone lines to transport high bandwidth data and provides IP services to subscribers. A DSL modem is required which converts an Ethernet signal from the other device to the DSL signal, which transmitted to the central office. DSL is a popular choice for IT departments to support home wreckers. Next is cable. Network access is available from any cable television providers using coaxial cable, which allows for greater bandwidth than the conventional telephone local loop. Cable modems provide an always-on connection and a simple installation. The Cable Modem Termination System, CMTS, which is a component located at the local cable TV office, sends and receives digital cable modem signals on a cable network, and it is necessary for providing internet services to subscribers. Next is wireless. Until recently, one limitation of wireless access has been the need to be within the local transmission range, typically less than 100 feet, of a wireless router or a wireless modem. The following new developments are changing this. Municipal Wi-Fi. Many cities have begun setting up municipal wireless networks for free or for substantially less than broadband. WiMAX or IEEE 802.16. Worldwide interoperability for microwave access. WiMAX is a new high-speed broadband technology that is just beginning to come into use. WiMAX provides broad coverage similar to a cell phone rather than through Wi-Fi hotspots. WiMAX operates similar to Wi-Fi but at higher speeds and over longer distances. WiMAX uses a network of WiMAX towers that are similar to cell phone towers. Subscribers must be within 30 miles of tower. Next is a 3G or 4G cellular. Increasingly, cellular service is another wireless WAN technology being used to connect users and remote locations where no other WAN access technology is available. Phones, tablet, computers, and laptops, and even some routers can communicate through the internet using cellular technology. These devices use radio waves to communicate through a nearby mobile phone tower. The device has a small radio antenna and the provider has a such larger antenna sitting at the top of the tower somewhere within miles of the phone. Next is the VPN technology. Due to the security risk, VPNs are needed when a teleworker of a remote office uses a broadband service to the access of corporate WAN over the internet. A VPN is an encrypted connection between private networks over a public network such as internet. Instead of using a dedicated layer 2 connection, such as a leased line, a VPN uses virtual connections called VPN tunnels, which are routed through the internet from the private network of the company to the remote site or employee host. There are several benefits using VPNs: cost savings, security, scalability, compatibility with broadband technology. There are two types of VPN access. Site-to-site VPNs connects entire networks to each other. For example, they can connect a branch office network to a company headquarters network. Remote access VPNs enables telecommunicators, mobile users, and extra non-consumers to access a company network security over the internet. So this is the last topic for today. Thank you for watching.